Have you ever wondered how your phone or computer can read your handwriting? You can scribble a note on your tablet and it magically turns into perfectly typed text. It's so fast and so accurate. It seems like pure magic. But what if I told you it's not a magic? It's just a little bit of math and an incredibly powerful idea from the world of computer science. That is the ANN or the artificial neural network. So, hi everyone, I'm Shaptarshi Mandal, just a regular computer science engineering student. And in this video, we are not just going to talk about this technology, we are going to build one from scratch and that can read handwritten digits also. So, this is the first step on a journey to demystify AI and so you how it actually works. So, let's just get started. The problem we are going to solve is something called handwriting recognition. Take a look at these numbers. For us, it's easy to see that this is a 7, this is a 2, and this is a 5. But how does a computer which only sees numbers and code figure that out? It can't just look at the curves and lines. A computer sees an image like this is just as a grid of pixels. Each pixel has a value from 0 for pure white to 255 for pure black. So for a computer, this number 4 is just a big list of numbers. And our job is to get our network to look at the huge list of numbers and say, yep, that's a 4. So, at its core, an artificial neural network is basically a bunch of smart experts working together. Think of it like a committee with a very specific job. In a general sense, a neural network has three main parts. First, we have the input layer. This is the first team that receives the raw data from the outside world. Next, there's the hidden layer. These are the true experts. They take information from the first layer, process it, and find patterns and relationships in the data. Finally, we have the output layer. This is the network's final decision maker. It takes the processed information and gives us the final result. All the connection between these neurons have a voting power called a weight and an internal gut feeling called the bias. This simple structure is what allows it to learn from the data. Now that we understand how a general neural network works, let's see how we can apply this powerful idea to a real world problem: handwriting recognition. A computer sees an image like this as just a grid of pixels. In our case, the image is a 28 cross 28 grid, which is 784 pixels. This is why our network is shaped the way it is. Our input layer needs to have 784 neurons, one for every single pixel in the image. The hidden layer is where the processing happens. For this project, we will use a hidden layer with 16 neurons to find all the different patterns in the handwriting. And finally, our output layer has to have a 10 neurons, one for each possible digit from 0 to 9. Alright, let's look at the code. This is what brings our new networks to life. Up here, we are just getting all our tools here. We are bringing in the main PyTorch library and some helpers we need like macro. Next, this is the data ready part. Means the first part gets our data ready for the network. It takes our handwritten images and turn them into numbers that computer can understand as. Here, the training and the test data loading part, and the data loader part. Data loader means it's a simple tool that grabs our data in a small, easy to handle in group part, so the data can easily handle and become small. Next, it is the model building part. This section is our network's blueprint. It tells the computer how many layers and how many neurons we have. This line is our first layer. It takes our 784 pixel numbers and gives them to our 16 hidden neurons. Thanks. This one is our second layer. Then this is the line we builds our final layer, which has 10 neurons, one for each number from 0 to 9, and all are fed from the hidden layer neurons. And This forward pass one, this line, this actually takes our images and flatten it into a single line of numbers. And this is the loss and optimizers part for the training loop actually. Here's the learning rate. And yeah, this is the training loop part where we actually doing the optimization, the backward loss calculation, and the optimization step for after the loss calculation, the optimization having into the weights. We are doing in five UV box in five training loops is going to be done. It can actually increase hidden layer neurons number from 16 to more like 58 or etc. Then the accuracy can actually reach up to 97%. Yes, 97% is just will neuron, will aid in neuron. Right. The first six images prediction, and yeah, as we can see, it's perfectly giving prediction like 7 is actually giving 7 to 2, etc. etc. So yeah, we can say that our neuron has network has actually learned perfectly. So yeah, that's the code execution part, and yeah, that's right.
What we just built is the fundamental building block for so many amazing technologies. The same core concept that let us read a handwritten code is what behind self-driving cars, facial recognition, and even the large language models that power tools like ChatGPT. This is just the beginning. By understanding how these simple building blocks work, you can start to see that AI isn't some black box. It's a tool that builds with logic, math, and some really clever thinking. What other magic tricks in AI would you like to see in later on? Let me know in the comment below. And if you want the code for this project, you can grab it from the link in the descriptions. Don't forget to like and subscribe to join me on this journey. Thank you, everyone.